All right, we're going to go through our final example of on 3.2D. Um, and this one is talking about outliers and high leverage points and how to find a least squares regression line. So what we have is, you've probably heard of practicing makes perfect, but does it practice also complete a task faster? Something to find out. A random sample of 15 high school students were taught how to solve a Rubik's Cube. They were each randomly assigned a number of times to practice a new skill. After they completed the assignment, they were timed solving the Rubik's Cube. And you can see the time in minutes, followed by the number of practices. Here is a scatter plot of the results that you can see from the least squares regression line. Okay, pretty cool. Describe the influence the students who have assigned to practice following the steps to solve Rubik's Cube. 14 times. All right, so if you look at this 14 times is going to be that value right there, has on the least squares regression line. And so what does that have on the least squares regression line? Well, right here, this is a far value, okay, so it is outside the pattern, so it is an outlier. And would that be considered a high leverage point? Probably, because it is farther out. And so on the equation of least squares regression line, because probably considered a high leverage point, above the least squares regression line, that would well, the slope would go up, that would go down, all right, and so that would decrease the y-intercept, and make the negative slope less steep. I'm going to say that, less steep. I think that would be great because it's going to get a little bit flatter. So this can go up, go down, and that's what's going to happen there. Now, describe the influence we were saying practice 14 side and the standard deviation of the residuals in R squared. Well, because this 14 is a outlier, okay, this point is an outlier outside the linear pattern. Outside linear pattern, and a significant distance away from the least squares regression line. That would do what? That would, all right, decrease the R squared value and increase the S value, the standard deviation of the residuals. That's what's going to happen here, okay? Standard deviation of the residuals. Hopefully you can read that. So the point is an outlier outside the pattern, linear pattern, and the significant distance away from the LSRL, that would decrease, all right, that says decrease the R squared and increase the standard deviation of the residuals. That's what I'm looking at there. And that hopefully makes sense as well. Now for the last one, it says the mean practice for this is X. So we know that the mean X values is 8. And we know the standard deviation of the X values is 4.47. We also know that the mean of the Y values, all right, the time is 7.71, and the standard deviation of that is 1.20. The correlation coefficient R is equal to negative 0.793. Find the least squares regression line. Well, this is what we're going to do. We're going to find out this by taking b sub 0 plus b1 x. So we're going to find our slope first. So our slope is going to equal the R value times S sub Y over S sub X. And you can maybe try this out yourself. You can pause this and see what the answers are right here. So we're going to go over here and figure out what that is going to equal. And so that's going to be negative, all right, 0.793 times our S standard deviation of our Y's, so it'd be 1.2, divided by 4.47. All right, and what we get then is going to equal negative 0.213. We'll go like that. And so from here, we're going to figure out our B sub 0. Our B sub 0, that's going to equal our average of our mean minus this B1, which we just found, times our mean of our x's. So we're going to put in 7.71, all right, minus negative 0.213 times, all right, our 8 right there, and that's going to be our y-intercept. So let's find this out. Let's take 7.71, and well, the negative makes it positive, so we're going to add that to 0.213 times 8. And what we get then is this right here, which is going to equal 9.414. All right, so we find our least squares regression line, 9.414. That's our y-intercept, plus our slope, or actually our slope is going to be negative. So negative 0.213 x, bada bing, bada boom, and we can kind of check that out. Yeah, that seems all right. And there we go. And that's how we do it. All right. So using high leverage points and outliers, how does it affect the least squares regression line and the standard deviation of the residuals along with the R-square value, and also how to find least squares regression line given the mean, which is a point on the graph. All right, so that is going to equal right here. Okay, so when we're looking at that point, that is where that y hat and our x hat are going to be. So that is our 1 point right there, and how this affects it moving up and down. All right, so I hope this helps you out, and good luck and God bless in the rest of your problems.